Hello everyone. In previous class, we discussed about what is the voltage regulation of the alternator and the method by using we can find out the voltage regulation of the alternator, like direct method or indirect method. So in this lecture, we will study about what is the harmonics in synchronous machine, the classification of harmonics like current harmonics and voltage harmonics. Next we will move on the slot harmonics in synchronous machine. क्या होते हैं इसके बारे में हम डिस्कस करेंगे कि व्हाट इज द स्लॉट हार्मोनिक्स और क्यों जनरेट होते हैं, व्हाट द रीजन बिहाइंड दैट. नेक्स्ट द एलिमिनेशन ऑफ हार्मोनिक्स और हार्मोनिक्स मिनिमाइजेशन फ्रॉम इंड्यूस्ड वोल्टेज. तो जो हमारा इंड्यूस्ड वोल्टेज है उसमें से हम हार्मोनिक्स को कैसे कम कर सकते हैं ये भी हम देखेंगे आज. And the reference of this presentation. So in this lecture we cover all this topic one by one. So let's start with topic number 1. What is harmonics in synchronous machine or synchronous generator as well as the synchronous motor? In electrical power system, a harmonics is a voltage or current at a multiple of the fundamental frequencies of the system, produced by the action of non-linear loads such as rectifiers, discharge lighting or saturated magnetic devices. So this is the basic definition of the harmonics. Harmonics क्या होते हैं? Actually multiple of the fundamental frequencies के जो current generate होते हैं उसको हम harmonics बोलते हैं. क्यों हार्मोनिक्स आते हैं? बिकॉज ऑफ नॉन लीनियर लूप्स सच एज रेक्टिफायर लाइट, डिस्चार्ज लाइटिंग और सैचुरेटेड मैग्नेटिक डिवाइस के कारण हार्मोनिक्स जो है वो हमारे वोल्टेज और करंट में हमें मिलते हैं. सो हार्मोनिक फ्रीक्वेंसीज इन अ पावर ग्रिड आर अ फ्रीक्वेंट कॉज ऑफ पावर क्वालिटी प्रॉब्लम. इससे दिक्कत क्या है? इससे पावर क्वालिटी जो है वो अफेक्टेड होती है. हार्मोनिक्स इन पावर सिस्टम रिजल्ट इन इंक्रीज्ड हीटिंग इन द इक्विपमेंट एंड कंडक्टर्स, misfiring in variable speed device or variable speed drive also, and torque propulsion in the motor. तो हार्मोनिक्स होने के कारण हमें बहुत सारी प्रॉब्लम्स हैं जो अभी हमने इसमें देखी हैं. हीटिंग की प्रॉब्लम आती है, मिसफायरिंग हो सकता है, स्पीड जो है वो वैरी हो सकती है ड्राइव्स की. तो इन सब चीज़ों को एलिमिनेट करने के लिए वी कैन मिनिमाइज दी हार्मोनिक्स. Now we will learn about harmonics in synchronous machine. We know that in synchronous machine or alternators means synchronous generator, the voltage and current are induced. These voltage and current are sinusoidal waveforms. But practically this doesn't happen. And sinusoidal waveforms are not reduced when such alternators are loaded. तो loaded condition में वैसे तो हमें pure sinusoidal waveform मिलना चाहिए वोल्टेज और करंट का, बट नहीं मिलता क्योंकि हमारा जो लोड होता है, लोड का नेचर क्या होता है? नॉन लीनियर लोड होने के कारण हमें हार्मोनिक्स मिलते हैं वोल्टेज एज वेल एज करंट वेवफॉर्म में. ड्यू टू द लोडिंग कंडीशन द जनरेटेड वेवफॉर्म deviates from ideal waveform. Such a non-sinusoidal waveform is called complex wave. By Fourier transform, this complex waveform can be shown to be built of series of sinusoidal waves whose frequencies are integral multiple of the frequency of fundamental waves. These sinusoidal components of harmonics function are called harmonics of the complex waveform. The fundamental wave is defined as the components which is having same frequency as that of complex wave. The component which is having double the frequencies of that of fundamental wave called second harmonics. तो हमारी फंडामेंटल वेव्स को हम कैसे डिफाइन कर सकते हैं? फंडामेंटल वेव्स वो वेव्स होती है जिसके कंपोनेंट जो हैं वो सेम होते हैं एज अ कॉम्प्लेक्स वेव के, और अगर ये डबल हो रहे हैं हमारे डबल ऑफ द फ्रीक्वेंसी मींस कंपोनेंट इन विच हैविंग डबल द फ्रीक्वेंसी ऑफ दैट ऑफ फंडामेंटल वेव सो कॉल्ड द सेकंड हार्मोनिक्स. अगर ट्रिपल हो रहे हैं तो थर्ड हार्मोनिक्स आएगा, सिमिलरली फिफ्थ हार्मोनिक्स एंड सेवंथ हार्मोनिक्स. While the component which is having the frequency 3 times that of the fundamentals is called the third harmonics and so on. The complex waveform contain both the even as well as the odd harmonics. Consider a complex wave which is represented by E is equal to E1m sin omega t plus phi 1, E2m sin omega t plus phi 2, and similarly E3m sin omega t plus phi 3 and so on, E and m sin omega t plus phi n. Where E1m sin omega t plus phi 1 is the fundamental component of maximum value E1m having an angle phi 1 from the instant of 0 of the complex wave. E and m sin omega t plus phi n represent the nth harmonics of maximum value E and m and having phase angle phi n with respect to the complex wave. Out of the even and odd harmonics, a complex wave containing fundamental components and even harmonics only are always unsymmetrical about the x-axis, where the complex waves containing fundamental components and odd harmonics only is always symmetrical about the x-axis. In case of alternators, the voltage generated is mostly symmetrical as the field system and the coils are all symmetrical. So the generated voltage or current will not having any even harmonics in most of the cases. The complex waveform of the voltage can be analyzed experimentally by using the phenomenon of resonance. What is resonance? Resonance क्या होता है? Resonance is the condition where XL is equal to XC. अगर हमारा इंडक्टिव रिएक्टेंस कैपेसिटिव रिएक्टेंस के बराबर हो जाता है तो दिस कंडीशन इज नोन एज द रेजोनेंस कंडीशन. If voltage waveform containing harmonics is applied to the circuit containing resistance, inductance and capacitance, then the circuit will resonate at one of the harmonic frequencies. The voltage drop across the resistance can be analyzed by using an oscillograph. The value of inductance and capacitance can be changed so that the resonance can be obtained at fundamental third harmonics, fifth harmonics, etc. The voltage on the oscillograph indicate the presence of particular harmonics like third or fifth and so on. So this is all about the harmonics. Next one is the current harmonics. The current waveform distortion can be quite complex depending on the type of load and its interaction with the other components of the system. Regardless of how complex the current waveform becomes, the Fourier series transform make it possible to deconstruct the complex waveform into a series of simple sinusoids, which start at power system fundamental frequencies and occur at integer multiples of the fundamental frequencies. If we focus, for example, on only third harmonics, we can see how all harmonics with a multiple of 3 behaves in a power system. So this is the waveform. In this, we can see the third harmonics wave. The power is supplied by a 3-phase system where each phases is 120 degree apart. We know that कि जो 3-phase system होता है, अगर वो system हमारा balanced है तो तीनों phase के बीच का जो angle होता है वो 120 degree apart होता है. This is done for 2 reasons. Number 1, mainly because 3-phase generator and motors are simpler to construct due to constant torque developed across the 3 phases. And secondly, if 3 phases are balanced, they sum to 0 and the size of neutral conductors can be reduced or even omitted in some cases. Both these measures result in significant cost saving to utility companies. However, the balanced 3 or third harmonics current will not add it to 0 in the neutral. As seen in the figure, the third harmonics will add constructively across the 3 phases. This leads to a current in the neutral wire at the 3 times the fundamental frequency, which can cause the problems if the system is not designed for it. That is conductor sized only for normal operation. To reduce the effect of the third order harmonics, delta connections are used as alternators. Or third harmonic shortage as the current circulate in the delta, the connection instead of following in the neutral of a Y connection means star connection. A compact fluorescent lamp is the one example of an electric load with a non-linear characteristics due to the rectifier circuit is used. The current waveform blue is highly distorted. So this is the blue waveform. It is called the current waveform, जिसमें कि हम देख सकते हैं काफी सारे हार्मोनिक्स हमें देखने को मिल रहे हैं. The next topic is voltage harmonics. So the voltage harmonics are mostly caused by current harmonics. The voltage provided by the voltage source will be destroyed by the current harmonics due to source impedance. If the source impedance of the voltage source is small, then current harmonics will cause only the small voltage harmonics. It is typically the case that voltage harmonics are indeed small compared to current harmonics. For that reason, the voltage waveform can usually be approximated by the fundamental frequency of the voltage. तो voltage harmonics mainly क्यों generate होते हैं? Due to current harmonics के कारण. If this approximation is used, then current harmonics produced no effect on the real power transferred to the load. An intuitive way to say this comes from sketching the voltage wave at the fundamental frequencies and overlying a current harmonics with no phase shift in order to more easily observe the following phenomena. What can be observed is that for every period of voltage, there is equal area above the horizontal axis and below the current harmonics waves, as there is below the axis and the above the current harmonics waves. This means that the average real power contributed by current harmonics is equal to 0. However, if higher harmonics of the voltage are considered, then current harmonics do makes a contribution to the real power transferred to the load. So this is all about the current harmonics and the voltage harmonics. After this, we will move on slot harmonics in synchronous machine. So the voltage generated in armature winding is derived assuming that the surface of the armature to be smooth. However, in practice, armature is not smooth but is made slotted. Due to this slotting, certain harmonics EMFs of undesirable orders are produced. Normally हमारा जो आर्मेचर वाइंडिंग जो हम करते हैं, फील्ड करते हैं कोर पे, वो हमारा स्मूथ कोर होना चाहिए, बट चूंकि उसमें स्लॉट और टीथ होते हैं तो उसके कारण हमारे कुछ अनडिजायरेबल EMFs वहां पे जनरेट हो जाते हैं जो कि हमें नहीं चाहिए. इनको हम स्लॉट हार्मोनिक्स बोलते हैं इन केस ऑफ सिंक्रोनस मशीन. The reluctance at any point in the air gap depends on whether there is a slot or teeth in the magnetic path. Since in case of alternators, armature is moving, the teeth and slots alternately occupy position at these points. This will vary the reluctance. तो रिलक्टेंस हमारा वेरी होता है बिकॉज रिलक्टेंस जो है वो डायरेक्टली प्रोपोर्शनल होता है लेंथ ऑफ एयर गैप के. अगर एयर गैप हमारा ज़्यादा होगा बिटवीन स्टेटर एंड रोटर तो रिलक्टेंस वहाँ पे ज़्यादा होगा, और जहाँ पे एयर गैप कम होगा वहाँ पे रिलक्टेंस कम होगा. The ripples will be formed due to the variation of reluctance from point to field point in the air gap, which is shown in a figure. फिगर में हम ये देख सकते हैं यहाँ पे कि जो रिलक्टेंस है वो हमारा वेरी कर रहा है ड्यू टू रिपल. These ripples will not move with respect to the armature conductors but glide on the distribution of the flux. These ripples due to slotting of the armature are always due to ripple opposite to slots and teeth which are causing them. Thus the harmonics which are generated in the EMF due to slotting is called the slot harmonics. तो slotting के कारण जो harmonics generate हो रहे हैं उन्हीं को हम slot harmonics बोलते हैं. It can be seen that the main source of the harmonics is the non-sinusoidal field form, which can be made sinusoidals, and the harmonics can be eliminated. The air gap offer maximum reluctance to the flux path. This air gap, if made to vary sinusoidally around the machine, the field form would also be sinusoidal. Even the air gap is made to vary sinusoidally, the field form cannot be sinusoidal due to the saturation in the iron parts, which is unavoidable. But there should not be the high degree of the saturation so that approximately sinusoidal waveform will be obtained. Thus, in general, it can be seen that ideal sinusoidal field form is very difficult to obtain whether the machine is salient pole type or cylindrical rotor construction. Now here we will learn how to minimize or eliminate harmonic components in synchronous machine. तो ये तो हो गया कि हार्मोनिक्स क्या होते हैं, कितने टाइप्स के होते हैं और कॉज क्या है, क्यों हार्मोनिक्स जो है वो मशीन्स में जनरेट होते हैं. नेक्स्ट स्लाइड में हम देखेंगे कि हाउ टू मिनिमाइज और एलिमिनेट दी हार्मोनिक्स. So the next is harmonics minimization from induced voltages. So in this lecture, we will discuss about how to eliminate or suppress the harmonics from the EMF waveform of an alternator. In an alternator, the primary source of harmonics in the EMF waveform is due to non-sinusoidal field waveform. If the field waveform would have been sinusoidals, then there have been no harmonics in generated EMF of an alternator. Therefore, first attempt is made to make the field waveform sinusoidal as far as possible. And then means of reducing or suppressing the harmonics is adopted. Field waveform of an alternator can be made sinusoidal by the following methods. Number 1. Small air gap at the pole center and large air gap at the pole end. In an salient pole machine tends to make the field flux sinusoidal. Skew poles faces if possible. In turbo alternator or cylindrical pole synchronous machine, the air gap is uniform and hence the field winding is distributed in slots in such a manner to make the field waveform sinusoidal. Figure shows the rotor of the alternator. Okay, so this is the diagram of the rotor for an alternator. Having adopted all the above mentioned methods, the field waveform along the air gap periphery is still not purely sinusoidal, but it is flat-topped. As a result, harmonic EMF is always generated in alternator. These harmonics can, however, be eliminated or suppressed by the following methods. The distribution of armature winding along the air periphery tends to make the generated EMF waveform sinusoidal. Number next, with corded coil, harmonics can be eliminated. If the xi be the cording angle for the fundamental flux waveform, then for nth space harmonics, the cording angle become n xi electrical. Therefore, pitch factor for nth harmonics is Kp is called the pitch factor, is equal to cos n xi by 2. If we want to eliminate the fifth harmonics, then xi is equal to 36 degree as Kp is equal to cos 180 by 2 is equal to 0. Therefore, generated EMF E is equal to under root 2 Kp Kd pi f nph into phi, where Kp is called the pitch factor, Kd is called the distribution factor, f is called the supply frequency, and pH is equal to number of turn per phase, and phi is equal to flux. According angle of 30 is most useful in an alternator as it gives the following pitch factor is equal to 0.966 for fundamentals and 0.707 for third harmonics and 0.259 for fifth harmonics and seventh harmonics and 0.77 for ninth harmonics. Mind that tripling harmonics is eliminated from the generated line EMF by star connection. Through fifth and seventh harmonics of reduced magnitude are present in the line EMF. By swaying, the armature slot tooth oblique slot harmonics are eliminated. स्क्वेइंग करना मतलब स्लॉट को सीधा डायरेक्शन में ला रख के थोड़ा कुछ एंगल पे टिल्ट करके स्लॉट को कट करना, उसको हम स्क्वेइंग बोलते हैं. Thus, using the above mentioned ways, harmonics in the generated EMF of the synchronous generator is reduced or minimized. So to eliminate or minimize the harmonics from the voltage waveform, the winding must be properly designed. The different way to eliminate the harmonics from generated voltage are: number 1, using distribution of armature winding. Instead of having concentrated type of windings, they should be distributed in different slots. The distribution factor for harmonics is comparatively less than that of the fundamentals and hence the magnitude of the harmonics EMF is small. तो concentration और concentrated winding की जगह अगर हम distributed winding use करेंगे तो हम harmonics को उसके magnitude को कम कर सकते हैं और minimize कर सकते हैं. Now second is chording. The EMF generated in the winding is proportional to cos x by 2 or n xi by 2. Previous वाली slide में जो हमने देखा था, where a is the angle of chording and x is order of harmonics. If proper value of angle of chording is selected, then the harmonics EMF can be reduced significantly. तो अगर हम कॉर्डिंग एंगल xi जो हमने प्रीवियस वाली स्लाइड में देखा था उसका अगर हम प्रॉपर वैल्यू सेलेक्ट करते हैं, सो वी कैन मिनिमाइज द थर्ड हार्मोनिक्स एज वेल एज द फिफ्थ हार्मोनिक्स. तो कॉर्डिंग के थ्रू हम हार्मोनिक्स को मिनिमाइज कर सकते हैं. नेक्स्ट, बाय यूजिंग द फ्रैक्शनल स्लॉट वाइंडिंग, द आउटपुट वोल्टेज वेवफॉर्म विल बी फ्री ऑफ हार्मोनिक्स बाय फैसिलिटेटिंग the use of fractional slot winding, as the distribution factor will be smaller compared to that with the fundamental. तो fractional slot winding use करने से distribution factor जो है वो हमारा छोटा होता है, जिससे कि हमारे हार्मोनिक्स जो है वो मिनिमाइज होते हैं और एलिमिनेट हो जाते हैं. So by using fractional slot winding we can minimize the harmonics. Next, number 4 is skewing. Skewing the pole phase will help in eliminating the slot harmonics. अब जो हम स्लॉट्स बनाते हैं रोटर पे, वो स्लॉट सीधा 90 डिग्री पे वर्टिकल ना करके उसको कुछ एंगल पे हम टिल्ट करके स्लॉट्स को बनाते हैं, इसको हम स्क्वेइंग बोलते हैं। तो स्क्वेइंग करने से हमारा जो हार्मोनिक्स है वो एलिमिनेट होते हैं। Number 5, large length of air gap. The reluctance will be increased by increasing the air gap and slot harmonics can be reduced. तो slot harmonics को हम कम कैसे कर सकते हैं? Air gap length को बढ़ा के between stator and rotor. So this is all about the minimization of harmonics and elimination of the harmonics. हम बहुत सारे डिफरेंट मेथड से हार्मोनिक्स को एलिमिनेट कर सकते हैं और मिनिमाइज कर सकते हैं। The next is references. So these are the references. And thank you for watching this video.